All right, well, thanks everyone for joining for our second installment here. We did have some time kind of at the beginning to get some people spun up onto the cloud instance, and we'll be doing that again through the course of this tutorial. So if you didn't get that done yet, that's fine. We'll be doing that in a minute. I wanted to give, so this is kind of a, this is the overview of the agenda we're looking at. So we're going to, start out with Phil Broderick giving us a overview of the Visions portal, which is now on the EMIT website that can help you kind of browse and understand what data has been collected, and also the forecasts of data that will be collected for those of you that are interested in kind of intersecting and collecting field data potentially. We had a lot of interest in that last time, so we want to kind of follow up on that, how we can facilitate that. And then we're going to kind of dive in with the LP DAAC folks to explore the EMIT data kind of directly from the cloud here. So that, and we're hoping that you guys are going to be kind of up and independent by the time we leave here today. So to facilitate that, we're going to have kind of two ways of asking questions. Like, we'd like to kind of handle as many questions as we can, but we're going to try to keep it a little organized. So we'll do kind of general questions, primarily for Phil, and then kind of high level data questions through a Mentimeter, which I have here, and we can also post this in the, I'll post this in the WebEx chat. And then for technical assistance and additional questions, we're going to have breakout, we already do have breakout rooms, and LP DAAC folks are going to be in there to answer specific questions and help you get logged on if you're having trouble or anything else. And so what you'll see is that under the participants, there's a main meeting, but then there's also breakout sessions here. And so you click on breakout sessions, and then you can join. Please join the technical help one first, and then we also have an overflow room in case we need to kind of help support a few more individuals. When you join that, this will still be, the main room will still be being recorded. So if you miss something, you'll be able to view it later once we kind of are able to get those posted. And then when you want to rejoin the main meeting, you just have to opt to leave the breakout session and click this leave session, not leave meeting, because that will kick you out of the meeting entirely. Though of course you can log back in if that happens. It won't be a total disaster. So let's see what else. Oh, so that you can participate in the breakout sessions, I am allowing participants to unmute themselves this time at the risk of chaos. So please please use your discretion in unmuting yourself, and do try to kind of ask questions through the channels we provided when you can, because we'll try to keep things kind of organized and rolling here. So I think that's it from me. I'll put the Mentimeter in the chat, and then are there any kind of questions at this point about how we're going to proceed? All right, great. Well, then I will go ahead and hand it over to Phil Broderick.
Right on. Well, thanks, Dana, for the intro. So as noted, we're going to kind of do this in two slightly different parts here. So the first one, we're going to talk through kind of data portal and data access before we transition over into this Jupyter session. So the first thing that I want to say is bear with us here today. Everyone that is logging in is a demo user. So thank you for participating in our giant trial. We haven't ever tried to have everyone log into the portal that I'm going to show you now before. So if everything crashes, well, we'll improvise on the fly, but I'm hoping that we have everything set up. So with that said, I want to direct folks that are online to the link that I've now just put into the chat. You should not need any login or authorization or anything like that to go. It should just be a normal website. And with that, I'm going to go ahead and start sharing my screen. Let's see. How does that view look for folks? Does that make it too small? Do I need to do this as a secondary screen?
It is small.
It's a
I can
it's
do
a
it.
little small.
Okay.
Can you just maximize it, or yeah, or whatever, however you want to do it.
Apologies. Let's try that. How does that work for everyone? All right, I'm going to go ahead and excellent. Assume that it's better. Great. Okay, so and please go ahead and toss into the chat and someone note to me if anyone's having any trouble logging in. So we're really excited to share this with everyone today. This is what we're calling Visions, which is our open data portal for accessing basic information about EMIT as it comes in kind of live hot off of our science data system. And I'm going to walk you through the usage here a little bit, and then and talk about how this relates to what the LP DAAC has going for you. So the first thing that I want to point out, we're not going to talk about it so much, but there is a using the map section down here that's got a lot of information. So if you need to come back and have forgotten what I've talked about here, head down there and you can get a lot of more information. There's also a map details and some FAQ page. So this entire experience is brought to you as an extension from what the MMGIS team, which is part of the Multi-Missions Advanced Concept program at NASA, has put together and is a tool that is used across multiple missions, including in support of the Mars rover. And we've adopted it for use with EMIT here. So what this portal lets you do is scroll around and take a look at a live feed of EMIT acquisitions that have come to date. So I'm going to kind of give you a little bit of an outline of what you can look to be using here. So if I direct your attention up to the top left on the corner, you're going to see a whole series of different options for you. If we click on layers here, just like many different GIS programs that you might be familiar with, you have the option of toggling different things on and off, and we're going to talk through kind of each one of them. So the two that are turned on right now are coverage and an RGB mosaic. So if I turn that RGB mosaic off by clicking on this white content, I'm left with just a base map on the bottom of the screen, okay? And now currently this is just the tiles of all of the coverage of EMIT data to date. So we kind of have our coverage here and we have our RGB map here, and we can kind of revert between those two. Okay. Up top, and I'm going to go in detail through the contents in a second, but up top, now we have a target mask as well. So this is where EMIT is looking to cover data for, all right, across the globe. So we learned a little bit last week about what that target mask looks like in concept, but this is the actual target mask that we use during operations. So this is the real deal. And then the next thing, and we'll spend a little bit more time on this coming soon, but we have the latest forecast. So this is where EMIT is planning to collect data over the next 2 weeks. And so folks here can be using that and thinking about things in a field planning context. All right. And then down on the bottom, there are 3 more layers. So right now we have a hybrid base map put up. You can turn that off, turn on a satellite base map, and or turn on an OpenStreet map if you prefer. But I'm just going to leave this in kind of a hybrid base map mode to start with. All right. So this is kind of our main portal, our main way of going through different data sets. We have a legend. Most of our legend entries aren't active right now, but those will come up in another day or two. So I'm going to skip past that. There's an info panel. This is critically important. So if I click on this info tab and I go to an example scene, so I'm going to scroll down here and look at one of our scenes from the Sahara. And I'm going to scroll all the way in here, and you should be able to scale and see kind of the full resolution imagery as you get all the way in. If I click on this scene, you're going to see a whole bunch of metadata that pops up on the left-hand side. Okay, those metadata properties are all from various processing steps that we have. They include everything from kind of the geometry of that file itself, the solar and the observation geometry. They retain a bunch of information about the retrievals. So what was the optical depth during the reflectance retrieval, and what was the water vapor in the atmosphere during the retrieval, as well as basic information like what was the UTC time, what was the file ID, and et cetera, et cetera. Now, the other thing that I want to draw your attention to is the series of links that are here. So there's a link for L1B observation files, L1B radiance, level 2A mask, level 2A reflectance, and level 2A reflectance uncertainty. So these are all the products that, if you recall last week, that we talked about that were available as net CDFs from the DAAC. And if you click on any one of these links, it's actually going to take you to go download data. So if I click on this, it's going to redirect. It's actually going to ask me to log into Earth Data Search, which I don't have populated, and I'm not going to type in front of everyone. But if I was logged in, it would just start downloading that data right away. If you want a shorter link, there's also links up on top for all of those properties that stay available even when you don't have the info tab open. So this is a way that you can get redirected right away to be able to download these data. Now, not all of our data, as you might recall from last week, have been delivered to the LP DAAC yet. We're working hard on that and getting up to an operational cadence. But so in the interim, what I've done is color-coded this page. So everything that you see in blue for all of these tiles out here, those are data that are staged and ready for you to go download. Everything that's in yellow, we haven't quite made it to staging yet and is not yet available for download. So if you go over here under the info tab, there's no link to be able to download, and you won't be able to do it. So bear with us, those are coming soon, and this portal is going to be updated as we continue to deliver those data sets. I'm going to toggle off the forecast here real quick and off the coverage, or come back to here and talk a little bit now more about some of the navigation that you can do on the system. So first of all, I'm going to continue down on the left-hand panel. There's a few more links that we didn't talk about. One of these is a copy link. So if you get to a particular view that you really like and you want to share with someone and say, hey, this particular region of the world is quite cool and I want to share that with other users, you can actually grab a static link here, which if you copy, it will create a new link, and you can go and paste that or share that with someone, and it'll take you right to this exact same view that you have set up. So it's just a nice way that you can conveniently scroll to a particular view. And then there's just a screenshot function. There's also the capacity, and I'm going to switch to this. I probably should have done it a while ago, to just enter a full screen mode so that you can maximize your capacity to view. And then down in the right-hand corner, you will see a latitude and longitude of the current location. If you select on this pick, go to coordinates section, you will also be able to navigate to different sections of the map. So I can do that and go to find, and it will locate a particular area on the map and zoom me to it. And then last but not least, I want to show off our time function. So you might notice that if I scale out, we have a lot of emit data that are coming through, which is incredibly exciting. It's also a little daunting to try to get your head around where these acquisitions are and to find scenes given the overlap. You can use our time slider feature. So this is going to allow me to drag and drop these bounds, and it will show only the data that is between those dates up and on the screen. Okay. So you can navigate this way. You can also use the calendar and clock to put in precise times over here on the left. And there are some fun tools over here for how you can be generating videos and things like that. I'm going to save those for a future time. One thing that I will note on this bottom panel is you have the capacity to zoom in and zoom out using your cursor. Okay. So you can kind of scroll around, and if you wait, give it a little bit of second to be responsive, you should see in these blue tiles where we have data that are available for you to be grabbing. So you'll notice that big gap in the middle, that was when EMIT was powered off. This is our new observations only, and if we move towards the newer sequences, you can see that all of these are yellow. So these are all pending staging to the DAAC. All right. So a couple other things that I want to highlight that you can do with these data sets, a couple other ways that you might want to search. We go over here onto the left-hand side into these layers columns. There's actually a settings tool right here. Well, there are a couple different options. One is a download button. So you can only download the vector layers here, but say you want for your project to download this layer and put it into your own GIS program, no problem, just hit that download link, you'll get a GeoJSON that you can load into QGIS or whatever your favorite program is. Right next to that is a settings button, and if you open that up, we have some control over the particular layer. So there's just an opacity thing, so I can slide that around, but then critically there's a filter option. So say, for example, I am only interested in, what can we do? I'll go to elevation, and I'll go ahead and say that I only want to look at elevations that are really high up. We'll say greater than 4,000 meters. If I submit that, then all of those observations are going to go away, and we're going to see that we're left basically with the Himalaya and the Andes. And I can refine that further by adding some additional properties. Let's say that I also want to say that the solar zenith angle is quite favorable. So let's say that that has to be less than 10 degrees. And submit that, and you'll see that, oh, now we only have a couple scenes that fit that particular criteria that are available down below, and I'll toggle that RGB off so you can find them. All right, so then you can go and, again, download those links promptly, provided that they were in blue, which currently they're not. All right, so that's kind of the content there. Next up, let me toggle back to this forecast, and this was one of the things that was kind of heavily requested from previous weeks. Which is not showing up for me. So I am going to do what I do when I get lost, which is just to do a quick refresh. And there we go. All right. So I'm just going to be looking at this future forecast right now. So a couple things that I want to point out to everyone, and we gave these caveats last time, but I really want to stress them here again. This is a forecast. It is definitely not a guarantee of where we will collect data. So there are a couple things that will indicate when we will or will not collect data. One is just operational cadence. So sometimes things happen on the ISS that deviate from our forecast. For example, in the next week, we actually anticipate that there is going to be a docking event on the space station, I believe, and that is going to throw off our actual acquisition forecast. So we will probably not acquire perfectly nominally as anticipated here. And not all of those kinds of events are baked into the forecasts, nor do we necessarily know what all of those types of events would be in advance. So this is simply a forecast. The other thing is the forecast quality degrades as a function of time, so it's not perfectly accurate. So if you look at one of these tracks and you are planning where you would like to do field work, I would strongly advise you plan in the center of a track, not towards the edges. The cross-track variation can shift a little bit. We can be off by something like 15, 20 kilometers in where we're anticipating. I would also avoid the very edges of the track, right? So over here or at the very end, we might not cover a location. The last major caveat to put into play is that we do not acquire data when there are very large and obstructive clouds. And we talked a little bit about the cloud mask last week, but we can quickly take a look at what that looks like in real. Go back to full screen here. Zoom in. Let me zoom in on a couple subsegments. All right, so here's a good example down here. So this is an area, so not recall that our cloud screener that's on board is extremely conservative. So we're only throwing data out when we're very confident that these are dominant clouds. So right here, this made it through our cloud screener, even though these are clearly cloud cover. But this area of data, you will not see an RGB data coverage for. And that's because we did not actually downlink any data from this area because it was so clouded. So if you had looked at the forecast over that region, you would not see any information there, right? If you looked at the forecast, you would have seen a forecasted acquisition there, but of course we don't downlink those data. So I want to pause here because I want to make sure that we have enough time to be talking about our main event, which is our Jupyter Notebook interface. But the last thing that I want to say here is that, again, we're putting this portal out there in order to attempt to be as radically transparent as we can about this system and to give you data as quickly as we can. But I can't emphasize enough that the LP DAAC is the authoritative source of all of the data. So if you want to know for sure about any particular data product, please do go to Earth Data Search. That is the authoritative location for things. This is just a quick way that we can provide you some additional information as we see it. All right, with that, I'm going to stop sharing. There may be some questions or things I didn't answer, and I'm happy to take those if we have time, Dana, or if you think that it's better that I try to answer things in the chat, I'm happy to do that too.
There's a couple that came in, so let me just ask real quick. Can the Visions GUI filter by cloud cover?
That's a great question. It certainly should be able to. I haven't added the cloud cover metadata tag to our collection, but let me write down an action item to add that in. We deliver it to the DAAC, so we do have those. We do have that information, and it will be able to. But I have to add it in. Thank you for the suggestion.
Great. And then there's a question that says, does that only apply to RGB or to infrared collects as well? And Aaron, you're welcome to elaborate on that question if you'd like, but I mean, maybe the question is there a CIR layer as well?
You said that if there's too much cloud cover, you don't download the RGB. I was wondering, did that also apply to infrared?
So if there is substantial cloud cover over the scene, we don't downlink any of the data, not just you happen to be seeing an RGB in that portal, but none of the data over a 32 frame section is downloaded for that region.
Great.
So you don't have anything there either. Yeah.
Great. And then I'll just do a couple quick comments here based on some questions. I apologize, I should have said this at the beginning. We did record last week's. We are working on getting it through our internal approval process. It has not been posted yet. I apologize. It was my hope to have it posted before, but we're doing our best and it will go up as soon as we can. And then another question is, where can you provide feedback? I think that if possible, it would be great to kind of receive feedback through the EMIT community Slack channel, so that we can, and I can make a channel associated with Visions more specifically, so people can ask questions there, and if we have issues come up, but that'll allow us to have a centralized location where questions can get answered, and then and they don't run the risk of getting lost in any of our email inboxes.
Yeah, please do feel free to provide plenty of feedback. This is a tool that you should expect to rapidly change over the course of the coming days, weeks, months, and possibly years as everything continues to evolve. So bear with us as things do change.
And I will put a link to how you sign up for the Slack community and or email notifications in the chat here in just a second. So, all right, thanks everybody. Now I think we'll hand it over and have Eric take it away.
All right, thanks, Dana. So I'm gonna paste a link here in the chat, and so if everybody can click on that, it should launch our cloud workspace where we're going to be running the Jupyter notebooks. If you didn't provide your GitHub username to us during registration, you can either re-register. We've got somebody watching that list and they'll add you, or you can put your GitHub username in the chat. We'll get that onto you. So share this. So when you do click the link, you'll get this, you'll log in and then you'll have these server options. Be sure to select the large 64 CPU with 512 gigabytes of RAM, the Python image, and the 2 CPU 16 gigabyte node share. And then you'll just click start, and that should launch the instance for you. There are a lot of people on here. And so supposedly we have the resources to handle this, but we may run into some issues. Just a heads up. So if you're having any technical problems, we do have a breakout room, and Aaron from the LP DAAC is in there, and he can answer technical questions or help you get logged in. If you have more conceptual questions, please try to put those in the Mentimeter that Dana linked at the beginning of the workshop. Otherwise, like, you know, if you reach out in the chat, we'll try to get back to you also. So I want to give everybody just a little bit of time to launch the cloud workspace. Sometimes it takes a while for them to spin up. So like if anybody is already having like any issues, feel free to unmute yourself and ask a question.
I can also real quick answer a question that came in on Visions while people are getting up to speed here. And then the question is Visions portal something other DAACs and missions are using, or is it unique to EMIT? And Phil can jump in here as well, but it's something that EMIT has adapted from the MMGIS team that has been focused historically on working on Mars and using it for kind of understanding where the Mars rover is going and planning that way. So I don't think it's currently being used for other Earth science focused missions, but correct me if I'm wrong, Phil.
Yeah, there actually, I believe there is one other Earth science mission that does use it, but it is not a staple of the DAAC. And there are many other planetary missions that do use it, but that does definitely include the Mars rover. But so no, I think you should think about this, and particularly the way that we have everything configured here as an EMIT specific thing.
Great. And I will start making that channel for discussion right now in the Slack. Someone does have a question about resetting their server option if they accidentally did not choose the large server the first time.
So for that, what you can do here, maybe it'll help if I share that.
So that might be a question that we could direct to the technical help if you want to keep going, Aaron.
I mean, I can share the, like, so you should come up with a screen like this. Just real quick, under File, you can log out and then log back in, and that should allow you to start up a new server. So everybody should see something like this after they get launched. I guess we can go ahead and move on. If it seems like everybody's in, I don't see a whole lot of issues in the chat.
Yeah, I think we're good to go. Maybe just a little orientation on what we're looking at in the Jupyter notebook.
Yeah, so this is like our cloud instance. It's a Jupyter Lab hub where we can open notebooks. And so that link you clicked, basically what it did was it launched this instance, and then it went ahead and it cloned the GitHub repository that we're going to use. And then it put you in there. So like you're already in the EMIT data resources repository. So what we're going to do, we're going to just work through one of the tutorials today on exploring the EMIT L2A reflectance. So in the tutorials folder, you can just click this bottom Python notebook to open it. And then if you want to get rid of this window on the left, you can just click the folder here. And so I also want to check and make sure my Zoom level's good. So if everybody can see this, can I get like some thumbs up? All right. Awesome. So for this notebook, basically what we're going to do is we're just going to walk through kind of exploring an L2A reflectance. And what I mean by that is we're going to look at the file structure of a netcdf using the netcdf library, and then we'll open it using Xarray. And so you'll see here, there's like a little bit of background and some requirements. You can ignore the requirements. This is more for if you're setting this up locally. And so in this workbook, what we're going to do, we're going to open an EMIT data set. We're going to walk through how to apply the geometry lookup table to orthorectify the image. We're going to make some plots of spectra and some spatial plots. And then like our last goal here is to be able to make an interactive plot that looks sort of like this. And what this plot will allow you to do is it's like sort of like a poor man's envy. You'll be able to hover over coordinates on the map and it'll relay the spectral curve on the right. And then you'll also be able to click to store one, like if you want to do a comparison. So we can get started here with the notebook. The first thing we're going to do is import all these Python libraries. And so to interact with this, what you can do, you can click in the cell, and then you can hit the play button here, or you can hold down Shift and hit Enter. And what that's going to do is that's going to run this cell and then move you down to the next one. Other things, like if you want to just go ahead and run the whole notebook, you can also do that. You can just click this double play button here to do that. And then since we do have so many participants, there is a limit on the memory and processing capability. So like if you do get an error that says something along the lines of like the kernel has stopped responding or it crashes, to get back started, what you can do, you can go to this kernel menu here up at the top, and then do a shutdown all kernels. And what that's going to do, I'll go ahead and do it. That's going to stop everything in the background. And then when you go back, to run a cell again, it'll have you select a kernel. You can just do the Python 3. You shouldn't actually have multiple options. I had another one left on here from testing. And that should get you back to where you are, and you should be able to run the cells and get caught back up. So these packages that we've imported, like I want to draw a little bit of attention to the NetCDF library and the Xarray library. So we're going to use the NetCDF library to sort of explore the data structure, to look at the metadata and kind of understand what the EMIT data looks like. And then we'll basically be placing that data in an Xarray structure so we can utilize different features from that library and also other tools that have been built on top of it for some of the plotting stuff. So next, what we're going to do, we already have the file that we're going to use downloaded to a shared location. So we're just going to set that file path right here. If you want to work on this like outside of the workshop and you clone this repository, there's a link here that'll allow you to download that file. You can just throw it in the data folder. But like I said, you don't really have to worry about that today. We've already got it in a shared location that everybody can access. So the first thing we're going to do here is open the data set with the NetCDF library. You can run that cell. That's great. I guess I didn't run this. And so when we look at this, the main consideration about the EMIT NetCDF is there are 3 different groups. And you can kind of think of the groups as like containers that store different parts of the data set. And so the main part is going to be like the reflectance. And then there's also a sensor band parameters group and a location group. So if we run this line here to read in the data set, we can see there's a lot of information here. And so we can see like a summary of the mission, the format, all the instrument, the convention used to write it, basically all the metadata that we would probably need for the data set. And then especially down here, I want to call attention to a couple things. You've got a spatial reference, And then you've got a geotransform that you can use with like GDAL. And then you've got your dimensions. And so you can tell that this is like a spatially raw format. It's in down track and cross track. And then it's got bands. But there's also an ortho Y and an ortho X, which is a separate layer that's contained within the location group. And that is basically how we can quickly reproject this data set. Then your main variable here is the reflectance. Some other groups, like I mentioned, are just the sensor band parameters and location. That's also listed here. So we can see all that metadata from this NetCDF library when we open the file. So if we do the same sort of thing and we just open the data set using Xarray, we get something a little bit different. So here it's putting the data set in like a labeled format that we can work with. All the attributes are here, including all the spatial reference and geotransforms, but one thing's missing. Like it doesn't have the group information, and that's because Xarray doesn't recognize the groups. So we have to read those in separately and then sort of piece them together to use this data set in Xarray. So in case we don't know what these groups are beforehand, like we can request the keys using the NetCDF4 library, and that'll show us these two groups here, the sensor band parameters and location. But now that we have these names, we can go ahead and open an Xarray data set for each of those groups. So if we open the sensor band parameters, we can see that it's got the wavelengths and the width that have maximum information. We can also see that those basically describe the band's dimension. And then if we read the location group into Xarray, we've got a lot more information here. We've got like the down track and cross track, which is the same shape as our reflectance. And we've got like each of those pixels has a latitude and longitude tag basically. And then we've also got elevation. Then most importantly here in this group, we've got the GLT. And the GLT can kind of be thought of as a way to copy the data from the raw spatial image into a already orthorectified shape. And that's basically done in terms of these cross and down track indices. So to get these into a single Xarray data set, what we can do is we can just use the merge function from Xarray. And that'll put them all here under data variables. And then we've got these dimensions up top. We've still got the attributes here. But one thing I'll do differently for the sensor band parameters is we'll actually use those as coordinates. So we can use these as coordinates for the band dimension. And what that'll allow us to do is use some additional features that you'll see when I go to plot things below. So this sort of gets the data into something we can work with in Xarray. And so I'm going to go ahead and delete these extra data sets now that we've all got them combined into this one data set. And then I'm going to go ahead and take a short pause for some questions.
Okay, there's a couple questions that are relevant to your part here. So one of them is Xarray over GeoPandas ? Any comments?
This is just one way to do this. I mean, you could, I believe, use GeoPandas. We mainly picked Xarray and I'm not sure about this for GeoPandas, but Xarray can also be used on like to access this data through S3. So you don't actually have to download the files. We can just access the Amazon bucket and connect and do our work beside the data if we're operating within the cloud.
Great. That's the only question that I had coming in on the tutorial component. The other questions I'm going to kind of hold for the end so that we can kind of keep momentum on the tutorial here.
Okay, that sounds good. So the next sort of thing we'll do is we'll just try to visualize this spectra. So what we can do is we can pick like a random cross-track and down-track location. Here, I'm just going to choose 660 and 370. And we'll use the select function from Xarray to do this. And then this is one of the reasons, I guess, also that we did use Xarray is this is a pretty powerful tool. You can use the labels instead of just numbered indices to do this. And so here we can select those, we run this cell, and we get a plot that looks something like this. And so here you can see a couple things. By default, like we've already got all the axes are labeled properly, which is very nice. You don't have to redo that work. And as I scroll in and distort this, just in case this happens to you, like you can just hit the reset button here on the plot, and that'll take you back to the default. And so here there are a couple flat sections that are water absorption regions. And these were removed and reassigned to a value of -0.1. If we want to replace those, we can do that with the same, with not a number, basically. And we can use that using like similar syntax as we would use with just like a NumPy array. And so if we do that, and then we again plot the data, you can see we just got rid of those. It cleans up the figure a little bit. And so next, if we want to take a look and plot this spatially, we can just select a band that we want to use. I just kind of arbitrarily picked 850 nanometers as the wavelength I wanted. And so you can use this sort of function here. That's basically going to find the nearest value to 850 nanometers. It turns out that's band 63, and then we can plot that. And so here we've got a nice annotated plot in cross-track and down-track of this wavelength. Pretty straightforward. One thing to note maybe is that I'd use this rasterize parameter here to save space. So if things look a little pixelated, that's why. If you remove that, it'll look much nicer, but it will take up a lot more space. So moving on to the orthorectification. Like I said, like this sort of process is basically, it's already been done for the EMIT data. And we're just using this lookup table to move the raw spatial data into a geographic grid with these ortho X and ortho Y dimensions. And just as a reminder, like we can quickly open the location group again from the data set. And so we can see that like this is going to be a much larger object with these dimensions and considering how many bands there are. And then that's part of the reason that this was not done for distribution. But we can see these dimensions, and so if we go ahead and remove those, we're going to use a tool. Basically, there's an EMIT tools script that we wrote that has a number of like helpful functions. for sort of automating the process that we did above. It'll take the data and put it into an X-array data set, basically just from the file path. And you can choose whether or not you want to orthorectify the image or not in that function. So if we run this cell here, it's going to import that. And then we've got just like a help function here that describes it. So you can just use the file path and you can define whether or not you want to orthorectify it. And then you can also specify if you want to use a quality or band mask, which are included in the mask layer. There's a separate how-to that sort of explains how to use those and how to generate the objects that are used within this function. You don't really have to worry about this GLT no data value or the fill value. Those are set by default for EMIT. So what we can do is we can run this EMIT X-array function. And that's basically going to consolidate all the work we did up above with getting the data into X-array. And it's going to go ahead and orthorectify it because we have that set to true. So you can see here, we've built this data set now. It's got latitude and longitude for the X and Y, and then it's got a band dimension as well. And so with this, we can now like plot it in spatially. So we'll do that quickly.
Oh, Eric, I think there's a question here. Could you just scroll back up for a second?
Sure.
Yeah, looking at the X-array data set, why is there under the spatial reference line, are we comfortable? Why does it look like nothing's there?
So the spatial reference is more like an attribute. There's not actually any, there's not any like real data there. It's just like empty, but it has the attribute which contains all of this information here.
Okay, great, thank you.
And like that's included here because it allows rastereo and Rio X-array to recognize the projection, so you can easily use those libraries with this data set.
Perfect.
Can I interject a couple questions that I think are kind of timely here? One of them is, do the GLTX and GLTY store each pixel centroid?
So I believe the lat and long that are included in the location group here are going to be like the pixel centers. But the GLT is basically, it's like an index. So the GLTX would be all of the, I believe it's the cross-track locations, and then the GLTY is going to be all of the down-track locations. And it's just prearranged in like a raster that has the right shape, and then those corners are specified in the attributes.
Okay, and then since the ortho X and Y are greater, or a greater number of pixels than the downtrack / crosstrack, does that mean that we're resampling? And if there's resampling, is it nearest neighbor or other, like linear bilinear?
So maybe Phil could better speak to like how the ortho rectification process actually works. Like this would just be like copying data basically to predefined locations.
Yeah, I think I can get to this directly. So the reason that the GLTs contain a greater number of downtrack and crosstrack pixels is that the GLT grid is in an orthorectified frame, right? So it's in, you can think of if your data, right, came in off an instrument like this, but then it was tilted diagonally. You might have a greater number of cross-track pixels once it's projected and a greater number of vertical pixels, right? So the locations there contain that, and then each pixel value should be constrained to the 1242 and 1280 cross-track and down-track dimensions of the core data set. As to resampling, yes, the GLT does infer a resampling distribution, and in our case, it is nearest neighbor only. So all spectra are preserved in going to the final location.
Great, thank you. And so then there's a clarifying question of, so does the emit underscore X array function perform all the steps that were provided above?
Yes, and maybe it does. It might do. It does a little bit more actually than what we've shown so far. There is like a more detailed how-to guide. It's like how to orthorectify that basically walks through what that function does in the background.
Okay, great. And then the last one on this kind of topic is X-array usable with CU pi, CuPi? I'm not sure how you, presumably it's a.
I am not sure about that.
Okay.
If somebody else in the audience knows, feel free to answer.
Feel free to put it in the chat if you've got
there are a
thoughts.
lot of experts in here.
Okay, great. Thanks. All right, I think seems like we covered it.
Yeah, and as Adam pointed out, and as I think we've seen before, Eric, you're going to kind of show an example of what Phil was just talking about in the next couple of plots. Yeah. Okay, great. So you'll also just get a visual any second here.
Okay, yeah. So back to doing some of the plotting. So we'll do another spatial plot here. Again, we're just going to select 850 nanometers as our band that we'll plot. And then here we're going to plot side by side an orthorectified versus unorthorectified data set. And so you can kind of see the difference here. You can see that it is rotated about 45 degrees. So hopefully that clarifies that a little bit more. Another nice feature that you can use, since this is an X-array, we can add tiles from the GeoViews library as well. So we can plot this on like an Esri imagery tile to sort of get an idea of where this is, how it looks. So I'll scroll out and we can see that this is along the side of Argentina here. If we zoom in a bunch, we can also see that like it lines up really well with this map. So that's good as well. And so that's sort of a basic spatial plotting overview. We can also do our spectral plotting now that we're in georeference coordinates. And first we'll just set those -0.01 values to not a number. But then one of the great things here is that with this select function, we can basically extract this point with this simple line here. And like there's another tutorial that we'll walk through next week about putting that into like a pandas data frame, just extracting a bunch of points from like a CSV. But we can basically extract the data from that point using a nearest method, and then we can plot that here.
And another question is, I think you touched on it before, but can you just remind everyone about the gaps that we're seeing on that plot?
Oh, so those are like the deep water absorption regions where the atmosphere would be like too thick, basically, to see what's going on there at the surface. And so EMIT set those to -0.01, and then I just masked them out from this plot by setting them to not a number.
And then, oh, this may be a tricky question, but at the very end of the wavelength, it seems like it's taking kind of a dive towards, okay, yeah. Is that, what is something specific going on there?
I am unsure about that. Again, maybe I'll ask Phil.
Yeah. So one of the things that we should be noting is that we're looking at water leaving reflectance here. So this is sorry, we're looking at the HDRF of the surface, but we're looking over a water feature. So anytime that you're certainly past about 1,000 nanometers here, the reflectance is effectively 0. You're seeing just a hair above that, right? Because our atmospheric correction process isn't totally perfect. And what you effectively start to see, especially as you increase out towards the higher wavelengths, is that any small, tiny deviations we have in the atmospheric model that we're using are going to resonate very strongly in the reflectance, as you see. So you start to see a little bit more noise come through. And that's just because the sensor effectively has no signal in these regions. And that's because the water is absorbing everything here. So we're effectively inferring what the reflectance should look like there.
Cool. Thank you. So here, like if this is something you want to do, you can save this object that we've built as a netcdf output that'll read right back in as is. But we won't do that in this notebook. It's commented out because it does basically copy the whole data set as it does it, and that'll use up a lot of our shared resources. And so lastly, we'll get to sort of the exciting part, is making these interactive plots. And so you maybe don't need to follow along the code exactly here, but I'll step through it. Like what we're going to do first is basically we're going to pick 3 bands to be our red, green, and blue bands. I just kind of picked 3 here that fall within that region. We could do sort of different approaches to this, but these are just the 3 that I picked here. And then we're going to do a gamma adjustment to brighten it a bit. Since a lot of these reflectance values are really low, it ends up being very dark. So we want to scale that a bit with this function. And what we're going to do here is build a new X-array data set that is just the red, green, and blue for plotting. And then to build the interactive part, what we're going to do is we're going to reference the latitude and longitude coordinates here. And then we're going to pull the data from our main data set that we built up above. So we can see here this new X-array data set that we built. And it's only got 3 bands listed here. And then we've got our different values. And so the first thing we're going to do is we're going to make a spatial plot of this and store that as an object. And then down here, we basically, we're building 2 functions. One that is going to select and stream the position where we're hovering the mouse. That's this point spectra. And then we're going to do the same for where we click on the map. And that's going to be our click spectra. And we're going to use these dynamic map tools from HoloView streams to plot that. So if we run this cell, we'll end up with this plot here. One thing I'll go ahead and mention before I get into that is over here on the right, if you have something like this, like a scrolling window within the window, you can right click on the side here and disable scrolling, and that'll get rid of that. That's like a common issue that a lot of people get frustrated with. Anyway, so back to this. By default, we just have 1 spectra displayed. But say, like, if we want to click and look at another water spectra over here, we can do that. And that'll store that. And then wherever we're hovering the cursor is going to display the spectra at that location. And it's going to automatically adjust the y-axis. And we did that so it would be easy to visualize the differences here. So you can see, like if you zoom in, like how different you can look within some of these fields and maybe see like the difference in the vegetation. Or you can see like difference in the like shallow water versus deeper out to sea. And so there's a lot of things you could do with this. It's obviously not as detailed as like something you could do in Envy, but like sort of qualitative exploration is a big part of working with the imaging spectroscopy data. So we thought this would be a helpful tool that people could use to quickly do that in a Python environment. Are there any questions?
I have a question. If you found a spot that you were really interested in, say that field that you had just been zooming in on, and you wanted to then save that spectra, you could probably go up to an earlier part of the tutorial if you note down the latitude and longitude and just extract that. Is that right?
So you could
And
do
like
that.
save it.
Also, you could edit this code here, where it pulls out this clip spectra, and you could save that as like a file, or you could write this in some kind of loop where you could click a bunch of places and it would record that for you in like a data frame.
Okay, great.
And then there's one other question here. Let me navigate back to it. There's a question about what are the water absorption region wavelengths that are we're converting to negative 0.1.
So those are the regions of the atmosphere where there's enough water that it's hard to see through. Maybe Phil could better explain that.
Yeah, and I kind of think that perhaps it's the actual like what are the what particular wavelengths are they, but I could be wrong.
Yeah. If you move to the next question, I am looking that up in the background to get you the exact answer there.
Okay.
We have a question in the chat here. Are there tools to generate granular average spectra? Mostly curious what those look like and assess the utility of averaging spectra at different spatial windows.
So I think there would be ways to do that, especially within this like sort of X-array data structure. But I'm not familiar with them. I'm sure there is a way. Maybe somebody else has some more experience with something like that and like how that could be useful.
Okay, yeah, that was.
Let me.
just my
I'll
question.
chime in with some points on both of those. So certainly you can do averaging of individual locations. You can average on kernels, and you can average all the way up to the whole scene. I don't think that we have any pre-built data to do that. You can, of course, do things as simply as using a command like warp to do it. If you wanted to go that route, or just some straight numpy calls to the X-array should be able to accomplish that as well. Once you have the data loaded in here, so definitely a good, or definitely certainly something that you can be doing. If I jump back to the previous question too about the wavelengths, currently our inversion strategy is blanking out the wavelengths between 1325 and 1435, and then between 1770 and 1965. And again, there is a metadata field that indicates exactly which one of those wavelengths are good and bad in the good wavelength. Now, the science team has actually discussed utilizing the predicted uncertainty, which also comes along with each one of these reflectance values in a different file, and utilizing that reflectance uncertainty to dynamically assign bad wavelengths on a per spectrum basis. And that's something that we're exploring in a future update of the data. And that would mainly be because in some regions of the planet, say particularly arid regions where there's very little water vapor in the atmosphere, you get quite a few more wavelengths than you do in somewhere like the tropics. And that's just because of how much gets obscured.
Great, thanks. We've got a couple of kind of questions that follow on from one another. One person is asking, are there tools to generate granular average spectra? Mostly curious what those look like and assess the utility of averaging spectra at different spatial windows. So I think that's kind of a question about
I think
our
that's kind of what we
tools.
just talked to. Yeah.
Okay, okay, just being sure. And then there's another question that is there an easy way to do that for spectral data? Oh, I think Bree, you might have answered this question in the chat. Apologies. Averaging spectra to like mimic Landsat 8, for example, or things like that. But yes, I think Bree did answer that, so we can count that. And then last one is the spectrum looks very smooth. Is there local averaging or smoothing going on?
Good question. No, there is not. These are individual pixels and these are individual retrieved reflectances. So that's both a testament to the high SNR, the high of this instrument, the spectral alignment of the instrument, as well as the atmospheric correction process used. So there's a variety of features that come into play there, but there is no smoothing that's going on.
Great. Bree, did you want to jump in?
No, I wanted Phil to clarify that that answer. I don't think I interpreted Carl's question correctly. Carl, do you want to ask your question out loud?
Sure, thanks. Yeah, I was just curious, and similar to the spatial question, does the code that you're showing here, which is great, thank you, this tutorial, does it allow you to sort of select the number of bands in EMIT that, for example, are in a certain, wavelength and average them? So it's like the same question as the spatial one, but for spectral averaging, I guess, is what I'm asking.
Yeah, so you could pull multiple bands out from like the X-ray object and average them, and so you could do that. Yes, I think that answers that.
One thing that I'll encourage is if you're attempting to do some sort of comparison to something like Landsat or MODIS or some of the coarser band resolution systems, is just a reminder to go grab that spectral response function from that particular instrument, because they might not use all wavelengths evenly, and you should perhaps think about that when comparing the two data sets, and you could use that as a kind of fancier average.
Okay, great. I think that that covers the questions that I've seen come in, so I think we can continue.
Okay, well, that's actually like the end of what we had planned for today for this tutorial. Oh, I think I did see one other question though. It was about the X-array, the EMIT X-array function, and so they're asking about the masking. And so yeah, that's going to be a separate array that you can build from the mask that's included in the mask layer. And then there is a how-to included in this repository that explains that. So if you go into the how-tos folder, we've actually got a lot of stuff in here. There's a how to use the EMIT quality data, and that walks through like how you can get that, and you can get the band quality. I'm sorry, the band mask information out of the data set as well.
Great. Yeah. Sorry, Carissa, I missed your question there. Did that get you answered?
Yes, thank you so much.
Great. There's a question down here about what was the rationale behind NetCDF format as opposed to NV. Nobody wants that question.
Yeah, do one of my DAAC colleagues want to start out with an answer there? If not, I can comment.
It's all you, man.
So NetCDF has been generally considered one of the preferred distribution formats for the DAAC. And so we kind of went with that standard. It's also been driven a little bit by the fact that the one of the end goals of EMIT, and of course the whole purpose of the mission, is to answer questions about radiative forcing in the atmosphere, which involves an interface with Earth system models, which traditionally use the NetCDF format. So there's a little bit of tradition in that for why this is a hierarchical format and not a pure binary file. It's also, I'll comment that it's to some extent an arbitrary decision. There is universally, everyone's going to want a file in a slightly different format. So our ethos has been to try to say, well, this is our delivery. It's got a lot of metadata in it, and to try to provide as many tools as we can to facilitate conversion and read into different resources. So certainly if you're having trouble utilizing the data for any reason, please do reach out on those Slack channels with any of software that you have in mind, and we'll try to work with you to make that a smoother process.
And someone has a question about where they can find the spectral response functions.
Good question. I will dig up a link here, but effectively the answer is that it is in the EMIT SDS repository that we put up there. And if you look at the EMIT SDS L1B repo, there will be a data section that will include the exact channel placements as well as full width half max of each spectra, or of each location within the spectra. Sorry.
No, great.
Oh, yeah, and it's in the NetCDF file itself.
Perfect. I was just going to say that I have, for those of you that are on the community Slack, there is an EMIT data channel, and I did pin the EMIT Science Data System GitHub link to the top of that channel so that you can always reference it there as well. Okay, and then there's a question about, for multi-temporal data, would you recommend adding time to the X-array data sets as coordinates, something like temporal coordinate, or other recommendations?
Yeah, I think you could add time. I would maybe, I haven't really put a whole lot of thought into adding a temporal coordinate, but like I think you should be able to do that. And that should still work fine with this in the format it is.
Great. Okay. Let's see. We're kind of getting, well, there's some additional questions that I want to come back to here on that kind of cover the whole what we've talked about today. But so keep them coming, folks. If you have more questions, we do have time here. So there's a question about when will the data on inferred mineralogy of the surface soil be available?
So I can take that one. So was it on inferred mineralogy or radiance or sorry or wavelengths associated with?
No, just the mineralogy maps.
Mineralogy. Okay. So I don't have an exact time frame for you. I believe that we are promising that they will be. Don't quote me on this, but I think that it's in April or May. I could be wrong on what our assigned delivery is. Effectively, what we're doing right now as a science team is reviewing data as they come in and making small tweaks to those algorithms to make sure that we have kind of a best-in-class first delivery. One of the primary things that we're waiting on right now is just for EMIT to cover some of the key validation sites that we need in order to really understand how well those mineralogical maps track with prior experience and with data collected from the field. So we're working to get those out to you as quickly as we can. But we're partly at mercy of when the ISS happens to intersect our locations, and we're partly all new to these data ourselves and trying to make sure that what we provide generalizes as good as possible to the whole world.
Great, thank you. So there's a question, more specific question about what is the best way to continue using and logging on to this JupyterHub after this tutorial? And then follow on, is there a direct link to the DAAC and this hub to avoid downloading the individual .NET-CDF files or an SMCE, thinking in terms of how to develop individual workflow outside of this hub? So, and Breed mentioned that the hub would be accessible for the next few weeks, but kind of as people think about going forward, continuing to use these data and developing those, can we kind of elaborate on how to move forward?
Yeah. So, yeah, I'll just say, the hub's going to be open for a little bit. I'm not sure what you mean by a direct link to the DAAC. But basically Eric's made the tutorials so that if you'd like to, you can adjust the endpoints to go directly to an S3 bucket while you're in this hub. And then go ahead, Eric, sorry.
Yeah. So like I think maybe you can continue to use this space for the next couple weeks, and that file is in a shared folder on here. But if you wanted to use this and download like a file to your own section or use S3 access, most of that information is in these how-to guides. We do have this how-to for the direct S3 access. And basically, you can take 2 code cells from that Jupyter notebook, and you can put it into any of these notebooks, and you should be able to use them. As for like downloading stuff, if you want to work with like a different granule other than like the one we shared, there is a how to find EMIT data using CMR, which walks through that, and at the end, basically, it uses a downloader tool that you can download that data to this location, or it'll generate like a text file of links, and you can use that with wget if you're on the JupyterHub instance here as well.
And then obviously you can also kind of just download the data and set up an environment on your personal computer. But so things are the cloud is kind of new. We don't have a science managed cloud environment set up for EMIT right now. But we will be kind of adding new resources all the time as we can.
Yeah, we do want to add resources. And if you generate some scripts for working with EMIT data, please like fork the repository. And you can add that stuff and we'll review it and add it to the repository. We would like to make this a space where people can collaborate on how to do different sorts of things with the data set.
Yeah, if I can just hop in with one other thing, and maybe I'll even share my screen very briefly here. I just want to point out this awesome resource that the DAAC has. If you go to Earth Data Search and you go to a particular granule, when you hit this download tab, you can of course download the individual .NET-CDF files, but if you click over here on AWS S3 Access, all of EMIT's data are cloud native, right? And so there's a description on how to check out your credentialing and get access on here. And this is very similar to what I believe what Eric was just referencing, but it's contained within each one of these individual links. So if you have your own AWS instance set up that's independent and you're doing some different workflow from, you should be able to use this documentation to quickly get your credentials set up and directly access those data. Eric, please correct me if I said anything uncouth there.
No, that's exactly right. Thank you for mentioning that again.
And I'm just going to add to the chat, we have a very generalized cloud data cookbook that we've been developing that we'd also love for you to add to. It doesn't have anything EMIT specific, and it's a work in progress, but it does have a lot of helpful information for working with different data types in the cloud.
Great. And then someone is wondering, will there be an EMIT users community where code is shared, or will forks be the standard manner to track and push code so that other people can access and there can be kind of a shared community?
I'll chime that I don't think that we have explicit plans at the moment. I would encourage you to use two resources. One, to ask questions on to the EMIT Slack. So that should now be a persistent space that should stay up. You can ask questions there. Hopefully we can get a community going so that you can start getting some collective responses to specific inquiries there. But then just echoing what Eric already mentioned, I think we would love the tutorials repository to be a home for much of this content and to be as pushing as much there as we can. So please do feel free to submit PRs there, and we'll try to be, particularly with that tutorials page, as inclusive and as responsive as we can to bring in a lot of your content there. So I think those are the two ways that we have planned right now, but if anyone has particular suggestions of things that they would like to see, I encourage you to put those either into this chat or into Slack, and we're happy to consider other options as well.
Okay, let's see. There's a quick question. Does the convert to NV code work for L1 as well?
It should. I believe that I tested it on L1 observation files, masks, and Reflectance. If you have any problems with it, post an issue to the page, and I'll jump on it.
Great. And there's a question about, can you directly process on AWS? Are there practical limitations, memory, or others?
You mean specifically on the cloud instance we're sharing, or like in general? Like I guess for this specific cloud instance, like there are like when you launch the server, I think it was 64 CPUs and 500 gigs of RAM. But like outside of that, that would be like something that somebody else would set up.
Yeah, just maybe to add to that, like minimum requirements to run like this notebook specifically, you do need at least 15 gigs of memory to execute the notebook in this environment. And so CPUs, I mean, we have it set at 2, but I mean, if you beef that up, it runs faster. But that there's just that one step of mapping those coordinate values to the GLT files, and that tends to balloon the memory a bit, but it does settle back down. But that's kind of what we had planned for this cloud space, was that we'd be able to accommodate about 15 gigs of memory for each of the instances that were started up.
Great. Okay, let's see. What else we got? Oh, there's a question that's been here about Visions for a bit. So is the Visions portal open source and available to install for our own data sets?
Yes, it is. I'm grabbing the link right now that I will put into the chat. So this is developed by NASA AMOS. The link is out there now, so you can certainly use it for your own applications if you'd like. There's a little bit of an interface here because a lot of what we've done is to so that's the link to the MMGIS portal, which is kind of the core technology that facilitates what we're calling Visions. Visions is effectively the intersection between the LPDAAC, the EMIT Science Data System, and MMGIS as a tool, right? So you kind of have to have all of those things working together and orchestrating all of that. And that's likely going to be specific to your particular project. So you can find most of our code out there. We have an EMIT visuals repository, which I think I need to make that open still. We will have an EMIT visuals repository that you can see a lot of our underlying source code for if you're trying to replicate some of those features, but the core tool is available.
Great, thank you. And then a couple of kind of questions that have come in about like how to kind of communicate with us. So Bria and Masha have put the sign up link here for email and Slack communications. The Slack community is part of the kind of broader JPL workspace, which is really nice because we don't end up with having things get deleted after 90 days and we can store them. But if you have already been involved with a JPL Slack workspace like EcoStress or some of the other ones that are out there, sometimes I can't tell if the invite, like I can add you, but it may not notify you, or you may have, we've had a little bit of issues with a few people kind of getting their accounts straightened out. So you can reach out to me and I can double check for you. If you signed up as of like half an hour ago during this tutorial, you would have been added by me to the community Slack, and so you should have received an email about that. And yeah, if not, please feel free, please feel free to reach out to me. I say as my inbox explodes, but yeah. And all right. I think I'm not seeing any further questions. So if I haven't said your question and it got lost in the chat, please feel free to interject at this point.
I have a quick question. What's going on next Friday? What are things looking like for the series next Friday?
Great question. So we're going to do advanced data manipulation next week, also highly featuring Eric. So Eric, do you want to give us any kind of sneak peek of what we're going to be doing next week? We'll also be sending out again an email if you attended this session, or if you've signed up for our email list, you'll get an email to kind of give you the agenda, and we'll also let you know about how we're proceeding with recording releases. So thank you for bearing with us on that.
So maybe it's not super advanced, but next week we're going to work through some of the how-tos included in the repository. We're going to look at like extracting a series of points, like if you have a CSV file with sets of coordinates, and then also basically do like an area extract or like a clip to like a region of interest. And both those are like pretty simple after you've got them in this sort of X-array framework.
Yeah, so feel free to kind of fool around with the scripts in advance and get on the hub, try them out, come with questions. It's a good resource, and it's a good space to try new things.
Definitely. I'll mention quickly that I think we're going to try to do a few dives into a couple different spectroscopic algorithms as well next week. Using these kinds of instances and using the data as set up, but to try to just demonstrate how some of the algorithms that many folks might be familiar with might be applied to these particular data sets and in this format and in this cloud instance. So we'll try to do some quick things there. One thing that I'll note is that we do still have a little bit of time before next week. If you have a topic that you don't think that we've covered and you're really anxious to hear more about, hop into Slack and let us know. And if we can put it together in time for next week, we would certainly be happy to support it.
And if we can't, then hopefully we'll be able to support it in future tutorial sessions, which we're planning. So awesome. Thank you, Leo, for the feedback. And I think we are happy, we have this time blocked out, so we're happy to stay on and continue answering questions or provide additional support. Yeah. Oh, the only other question I realized I didn't answer is EMIT on social media. Emissions often don't really have their own individual social media presence, so it is kind of EMIT activities are promoted through the DAAC and Earth Data, and also through JPL and NASA Earth Sciences. So that's kind of where you'll see those levels of updates. And if you've signed up for our email list, we will probably also be sending you out some information from time to time to keep you updated, but not swamp your inbox.
Great. Well, like Dana says, I think I at least will plan on sticking around if other people have questions in the weeds, things that they want to poke around with on the notebooks. I think the rest of us will stick around, but I think that concludes the primary content we had for you today. So thanks everyone for joining us.
The formal session is ending. And so we'll actually stop the recording as well now. So this will kind of be the end of that. And so then if we have kind of a more chit chat discussion, that'll be offline. So thanks everybody.